So I started the recording. We'll wait till time to start, but
Trying to put everything back in order here also from the storms we've had, knocked everything off.
yes.
Oh,
And I forget to reboot this machine.
Well, I'm gonna, even though some people aren't here, I'm gonna get started. So welcome to the July 18th, 2023 session of TangerineSDR and Hamside Technical Session. My name is David, KV0S, and this week I've been working on K9 radio. I have had it running for over a month now, but there's a few little things that seem to baffle me. So I may have some questions for Phil later. But that's taken my time. Also, my wife's had a little bit of illness, so I had to deal with that. But otherwise, that's it for me. Next on the list is Michael, AAAK. Go ahead, Michael.
well, thank you. Greetings to everyone listening. Back to you, Dave.
Okay. Next on the list is David, KD0 EAG. Go ahead, David.
Hello, everybody. Just been plugging away. Just let you get back to the list.
Okay. Oh, by the way, the things you sent me did work. I did get them working. So
Good, good.
next on the list is Bill, Engelkey, AB4EJ. Go ahead, Bill.
Thanks, Dave. Well, I was on vacation this past week and went up to Detroit to see my son and his wife and their new baby, and our daughter and her husband and their 4 kids met us there, and we did all things in Detroit, and then we drove over to Niagara Falls on the Canadian side, and a good time was had by all. So I got back on Friday, and over this weekend played with my RX 888 a little bit and got it working, and wrote a little program that substitutes in for PCMCAT, which takes the data and it outputs a single channel, a single frequency to a UDP port, which I can then read in through using GNU radio. The objective there is to make something that's comparable to what I've got running on the Grape side, where you can observe the Doppler shift in a given frequency using the GNU radio. The one thing that I haven't figured out yet is the data is in a different format. The particular format that is coming in, I haven't really figured out yet. I mean, I think I know what it is. I think it's signed 16-bit samples. That's what I think it is based on the documentation I've been able to find. However, okay, I don't know if it's little Indian or big Indian, but all I know is that either way, when I try and I process it through the same GNU radio process that works well with Grape, all I get is a screen full of noise. So obviously I'm doing something wrong. So maybe somebody can give me some tips on that. Anyway,
check the byte order of the samples.
Say again?
Check the byte ordering of the samples.
You know, you can look at there is a sample of Phil's code where he does reverse the bytes from the sample order to network order, whatever it is. And I've implemented, just recently added a WD record.c, which is in there. It runs and writes out WAV files that are understood by the WSJTX's Whisper D and JT9. So you might, I think if you do a get pull from you could look at my code, the wd-record.c, and you'll see how to take his feed and write it to a WAV file.
Well, I don't want to write it to a WAV file. I want to output it as a UDP stream. Are you saying it's the same thing?
Well, it depends what your destination is, of course. So I
My
don't know.
destination is GNU Radio. My destination is GNU Radio. I
Okay.
want to read it into GNU Radio and then process
Oh,
it from there.
okay. I don't know what format it wants, so I'm not a good
Yeah.
source.
Well, I mean, there's blocks in GNU Radio that will let me take whatever it is and manipulate it in any. What GNU Radio needs is complex 16-bit 32-bit floating point, complex 32-bit floating
Okay.
point. And it's very easy to convert the 16-bit samples into that using blocks in GNU Radio. However, I haven't been able to successfully make it output a signal yet. I mean, still working on that. So if anybody has worked with it in GNU Radio, please give me a shout. I mean, I've got the code. The code is in PCM cat that takes and flips the bits around to move it from little endian to big
Okay.
endian.
Okay. Then you
And-
know more about it than I do. I think I confess that. And Phil, I think is your the right source
Right.
for your help.
Well,
Okay, well, we can come back to that during the discussion.
Yeah.
Back to Dave, and then he can manage the rest of the session. We'll come back to it later.
oh, okay. Well, let's go on down the list. So next on the list is David McGaw in one HAC. Go ahead, David.
Good evening to the net. Besides life's just normal hassles, we've got have to move my 94-year-old father into a new place this weekend. That's going to be a lot of fun. And we've had a lot of thunderstorms here, flash flooding and all that. Luckily, I haven't had it right immediately, but like 2 roads over got washed out the other day. And then of course our regular research projects, but I do have an RX 888 Mark II, and I've been trying to figure out the best way to bring it up quickly. I'm a little daunted by the Raspberry Pi side, though. It's just a matter of sitting down, I think, and reading the instructions when all else fails. The one thing that I have a question is if anyone's brought it up under Windows, because I'm not figuring out how to get the right driver without having to download the whole 270 megabyte package from Cypress to get just the driver. If anyone has a clue of that, we can talk later. But one of the reasons I want to get it up reasonably quickly is I do have, because of some of the other things I've done, I actually have the cable for doing an external reference. So I want to get it up going with external reference and see what we can do with that. So back to Nat.
Very good. And let's see, Robinette has jumped to the top of the list. So let's let him go. AI6VN. Go ahead, Rob.
Okay, well, I'm sorry, I jumped in there with a bill too much. I have just started to, I finished a kind of alpha level integration between my Whisper Daemon software and Phil's K9Q and the RX 888. So I've had the opportunity, since I have that system is running out of KFS, I've had the opportunity to compare it directly 1-for-1 against a Kiwi. And it's startlingly better. We have much work to do to understand how to optimize the 888 and 9Q, and I don't know yet the source of the improvement, but I'm getting sometimes I'm getting 33% more spots from the 888 than I am getting from a fully optimized Kiwi. I mean, Kiwi has a bandpass filter in it, upper shelving filter. It has 15 dB gain LNA. So it's that Kiwi has been tweaked on for several years. And as far as we know, until now, it has been the most sensitive receive device, wideband receive device we've had. So the 888 is very encouraging. And we've just now, in the half hour before I've logged on here, brought it up also, a 888 in Europe, a Whisper Demon 888 system at OE9 GHV, who has probably the most sensitive Whisper receive site in Europe. So we now have 2 of these systems in operation, and in both cases we can compare them. Now this is, we're only looking at Whisper performance, of course. I'm not looking at other things, but I'm doing the comparison between the 2 of them, and we can objectively compare the number of spots between the 2. The spot counts are exactly the same. RF is going into both systems. So the results are very encouraging at KFS. We haven't looked much into the frequency, accuracy, and stability, but I did look briefly and compared frequency stability, FST4W spreading values, which are a proxy for the drift. We have several transmitters that are GPS discipline transmitters, including one that's not too far from KFS. And once again, I don't understand it, but the RX 888 seems to be doing better than a Bogner disciplined Kiwi. I mean, it's so again, more investigation is required, but the 888 is absolutely surprising me so far, but this is all preliminary work. We have a lot more investigations and calibrations and measurements to do, but I just can't imagine how the 888 has a more stable oscillator than a Bogner. So that's an anomalous.
And just for clarification, there is no external stabilization crystal, right?
No, the RX 888 is stock out of the box, and
Okay.
I just can't imagine how it can be more, have a lower spreading number. But on the other hand, we're only looking at the spreading numbers reflect the stability over a 2-minute period and the phase noise, and over the 2-minute whisper period. So I perhaps I know the Kiwis, well, the Bogner has excellent phase noise response, so I can't see how the 888's oscillator is any better than the Kiwi. So to me, this suggests a measurement error and not a better performance. So, but in any case, the results are startlingly good, and so I've ordered a bunch of little jumper cables and I will modify the 888 at KFS. I can't do the one in Austria myself, but I'm going to do and I've ordered 5 more 888s. I'm going to convert everything, free all the Kiwis that I operate at 3 sites. I'm going to free them all for doing what Kiwis do best. But whisper reception, I think the 888 and Phil software seem to be a real step up in performance. I'm really surprised and pleased, of course.
Very good.
So Phil and I are looking at discussing various, ways to communicate. We have to deal with AGC. Yeah, I'm running right now with, the AGC enabled on the 888. The Kiwis are fixed gain, so there may be some advantages to the AGC, but the AGC then invalidates the background noise level measurements, which provide us that are included with each spot. So the AGC makes those no longer useful. The noise measurements are no longer useful. So we need to, there's more work to be done to fully integrate his software and the 888. But Phil, I think, well, I'll let him speak for what he's done on. That's what I've done.
Okay, well, very good, Rob. And now next on the list is, let's see, Jim, K4BSE. Go ahead.
Good evening, all. Well, I'm trying to get back in the swing of things after lying out on the beach at Siesta Key, Florida, all last week, and it's kind of hard to get back in the groove. Spent some time this afternoon out in the yard, and it got me worn out, probably from the heat as much as anything. Anyway, as far as progress goes, thanks to the patience of Dave Whitten, I have my magnetometer working, I think, on the bench. The next challenge will be to get it in the ground and try to get it running there. And I think I'm a few days away from that, but I think I've got a plan that we'll get it in the ground within, I'll say, a week or so. And then I will turn my attention to the RF version of the grape. So that, and I've got to repackage everything a little bit. Got someplace else I want to package it and power it differently. So I may be down for a day or two while I do that. I'm not quite to that point yet. That's about all that's relevant here. Back to net K4BSE.
Very good. Next on the list is Dylan R. Go ahead, Dylan.
Yes, 1 second. I'm having trying to get my Bluetooth to work.
Well, we can hear
Dave.
you.
Okay. Yeah, my Bluetooth's a pain in the butt right now.
Okay, well, if you want us to skip over you, we can.
Can I go? I was just trying to get my Bluetooth to work, but that's it. But a lot's been going on. Haven't really had time to come back on. So yeah, a lot of stuff. But I made it today and ready to keep listening. So
okay. Well, thanks for being there, Dylan.
You're welcome.
Okay. Next on the list is Joe W7LUX. Go ahead, Joe.
Good evening, everyone. Things are just plugging along here. And for Dave, trying to remember how I did this, but I do have the RX888 working with one of the consoles, and I vaguely remember there's something called EXIO _SDDC _hardware. And I'm looking around now. Are you good in the are you good at arrl.net for email?
Yes, I am.
Thank you. Thanks, Dave.
Okay.
Excellent.
Okay, Josh, Dev, Joshy, do you want to go? Dev?
Good to see you.
Yes.
There he is.
Yes. Good evening, everyone. I came back after a long time.
Yes.
Actually, I wanted to say hello, and I wanted to make a request. I wanted to catch Nathaniel. I think he's not here today.
He is in Europe right now at a conference in Switzerland.
But nevertheless, I wanted to make a request. I wanted to make a request to him, but I think I would want to make a request to everybody in the group. I lost a job. I had a job recently and I lost a job, unfortunately. So I'm looking for jobs, and I I wanted to discuss this with Nathaniel. And but if it is helpful, anybody in the group is looking for someone to work with them, I'm looking for a job.
Okay. Well, it sounds good. Well, we hope that you get one.
I would greatly appreciate any leads, any recommendation, any connections on this regard.
Okay.
Yeah.
Very good.
Thank you.
Next on the list is Jonathan, KC3EY. Go ahead, Jonathan.
Hi, everybody. I've been pretty busy this week. I've been working on two major things. One, I'm working on a proposal and a budget, or at least a parts budget for VLF system kits. The plan is to make 10 or 20 kits similar to the system that I installed at Nathaniel's location, it'll simply just be a PVC pipe with the preamp and the VLF antenna inside, the back end box with the Raspberry Pi, the GPS antenna, the cable, everything required, and they would simply install it in their rural backyards, and it'll be something similar, kind of similar to the magnetometer kit, but more of a complete unit. So I have to kind of do the design, make the design modular, easy to reproduce without much labor, you know, instead of making pigtails and cable adapters and things, say for the reset button or the status LEDs, I would just get right angle mounted LEDs and drill the appropriate holes in the case, things like that, to make it more modular, less parts. So I'm kind of working on that and figuring out what I can do. And also I have to figure out a science case. I want to do a lightning location network, but I also want to capture data for the eclipse. So I have a lot to think about. And if anybody, so I'm also asking for any volunteers that would be willing to perhaps assist me or in the development or manufacture of these kits. If anybody would like to, please let me know. Everything is very preliminary right now, and I'm kind of figuring everything out. But if anybody is interested, the unfortunate thing is that I don't have funding yet for the kits. But even if I don't get funding this time around, I'm still going to be working to get funding. So it's not going to be in vain. I definitely want to get these kits going. So if anybody does have some free time and wants to help out, just shoot me an email. Also, I've been working on something. This is the 3-channel VLF system. This is the what I call the back end box, where the you can see the cable glands on the left. That's where the feed line cables from the E field receiver and the H field receiver, 2-channel H field receiver. That adds up to 3 channels. That gets connected to these green screw terminals over here. There's some interfacing circuitry, mainly lightning protection, isolated DC to DC power converters, audio isolation transformers, main buck converter to supply power to the Raspberry Pi and the GPS. The Raspberry Pi, you can see, has a sound card on top of it. That's the audio injector Octo. It has 8 audio outputs and 6 audio inputs. It has 8 audio outputs as well. However, the last 2 are from a digital port on the codec that's not used, so it's only 6. But I'm only using 4 here. The PPS signal from the GPS has to be fed into the sound card. And what I did was I connected it to a potentiometer to vary the level, so it's about 80% of the sound card's full scale. The problem is that I didn't want to create a situation where the pot is turned all the way down, and the pulse per second is shorted to ground. So I added a 2K resistor. But the problem is I put it in the wrong place. It's supposed to go from one end of the pot to ground, and I connected it to the signal input. So I have to fix that. The board is very compact, and so it's going to take some mangling to fix it, but I'll get it fixed. On the left, or on the right here, the top right, you can see the I have an old Trimble GPS module mainly for testing, and the interface board that has the DE9 connector on it. This whole system, once I get it complete, this is going to be accepting signals from 3 channels. So that would be an E field receiver and 2 H field receivers. So I'm slowly getting this together, and next I also have to work on the H field receiver. So I'm obviously extremely busy. Lastly, there was some really good discussion on the GRAPE message board regarding the timing system of VLF-RX tools and how it worked. John he had some questions about how I could achieve that kind of performance using common off-the-shelf stuff, and so I went into detail about how the VLF-RX tools utilities VT card and VT time, what they do is they actually measure the latency for each sample, and that measured latency is provided to the next program in the chain. So from VT card, it takes the sample and it also measures the latency. Then that gets fed into VT time, and it takes that calibrated latency and it combines it with the latency that it measures from the GPS pulse per second. So it continually calibrates out this latency and it corrects for it continually. And this allows at least my system with a fairly mediocre oscillator to get down to the timing error of hundreds of nanoseconds. This is definitely good enough for VLF amateur work and spherical location and other sorts of applications like that. And I invite everybody to take a look at the message. There's a lot of good information about how the timing system works. So I hope other people can get something out of that too. That's all I have. Back to the net.
Well, thank you, Jonathan. That's quite a complete rundown of what you've been up to. Next on the list is Majid. Go ahead, Majid. Microphone.
Good evening, everyone. Sorry for the delay. Just trying to find the microphone. Last week I was off doing my wife's surgery, so I don't have much to say. But this week is going to be a busy week for me. I got the plans structure to build these, modify this RX-888. So I did order the cable for SMA, and I'm hoping to receive that by mid of the week, and with eager to build this to see what's the difference. And also we got the stands structure for saving the digital RF for our group, and I'm sure that our students going to be busy with those. We're gonna be busy for building the GNU radio, some codes for that, and all of us are pretty new for this, so it's going to be challenging this week. That's it. Back to you.
Okay, and next on the list we have Michael, AC0G. Go ahead, Michael.
Good evening, everybody. I received some pigtails so that I can try to connect my RX-888 to a Bodnar for some discipline. I've had a little trouble, but I've been attempting to build the SOAPy SDR modules so that the output of the RX-888 can be input into GNU Radio via that mechanism, or to GQRX or anything else that's prepared to receive those that can use the SOAPy framework. I've been frustrated in my attempts, and it's entirely due to my inexperience with C programming to get some consistent performance trying to use KA9Q radio. It worked last week for me just fine, and I was able to listen to all of the WWV frequencies this week. It's not working, and I don't know why, but there it is. I keep plugging away, and I'm hoping that the RX888 looks like a really promising platform. I'm excited about its use and about all the expertise of you guys that is hell-bent on making it work. So back to that.
Okay. Next on the list is Phil, KA9Q. Go ahead, Phil.
Okay, I don't have a whole lot to say here, and I'm getting ready to go out for a local meeting. I'm a little concerned, Michael, that if it's working for you, then not working. Maybe we take that up offline.
Yeah, don't be concerned. It's almost certainly my error, but I was curious how you ended up in the Mar-a-Lago bathroom.
You know, are you aware of Clint's pages about setting up, installing and setting up the K9Q environment?
Yes, I am, and I've been poring over them, and I found them very, very useful. And I have to excuse my ignorance. It is in no way a reflection of your code, which I am deeply appreciative of, Phil. So, but I still need an explanation for the Mar-a-Lago bathroom.
I get around, don't I?
You sure do.
Phil, do you have any more?
Not right now, and I got a couple things else going, so I'm kind of
Okay.
out of here.
Okay, next on the list, we've talked to Rob, so is Tom in 5EG. Go ahead, Tom.
Oh, good evening, Dave, everyone in the group. We've got the receivers in Scotty's hands for rework. So he's got 4 receivers, the one from Majid, Dave, John Ackerman, and myself. And he got those last night. So he's going to try and get those reworked and see if we can figure out what's going on with the connector. Dave, can I do a screen share here?
Sure.
Okay, I've got a, is this chart show up okay?
Yes.
Okay, I've got a survey grade GPS antenna from John Ackerman, and I've got that in a permanent installation. And I've started off by measuring an old HP Z3801, which is a Telecom grade double oven crystal oscillator that's GPS disciplined. This uses the old Motorola Encore, I think it's Encore receiver, which has a few timing issues. But this outlines the performance I'm getting on the oscillator compared to GPS time. And John said it's about an order of magnitude worse than what he would expect the clock module to give. And I have not yet instrumented to start measuring the clock module's performance against GPS time. What it shows, the top line is the maximum time deviation over about 40,000 seconds of the oscillator PPS time versus GPS time. And it's in about the 70, 80, 90 nanosecond range. The RMS is about 15 nanoseconds error between the GPS time and the oscillator time. And then below are the various Allen deviations of the time distribution. So you can see it's a couple of nanoseconds up at 10 seconds time interval and declines pretty much at a per octave slope. down. John says the slope is about what he would expect. So the oscillator performance and antenna performance are pretty good. Hopefully in the next few weeks, I'll get instrumented to start comparing the clock modules time against this. So that's it. Back to the group.
Well, very good, Tom. And thanks for getting those radios off and continuing to work on the timing board.
Yeah, hopefully the hardware will do us some good in the future here.
Oh, yes, I think we can find some uses for it. Next on the list is Win. AI4MV. Go ahead, Win.
Hello, everybody. I think this is my second visit here, and I'm feeling way over my head. I'm just trying to figure out what's going on with what.
Well, there's
looks
like
a lot
3
of
or
good
4
stuff
projects
going on.
being talked about. So, are you done?
Yeah.
Okay.
I'm just glad to be here.
Well, I think that gave everybody a chance to talk, and so we're open for general discussion.
Yeah, first off, you're talking about the receiver card rework. I should send mine to Scotty, I guess.
Yes, you do need to, Dave. And I don't know, Majid, do you know if Nathaniel had more than one receiver board?
No, we just had one.
Okay.
Yeah.
Very good. Yeah, I'll do that.
Yes.
I presume he has a new address.
Yes, he does. And it has 3 or 4 variations, depending on who you talk to.
Maybe I should get it from Scotty's mouth.
I'll send it to you.
Oh,
David.
that would be good. Thank you.
Yes. And he is not in Utah. He is in Phoenix.
Okay.
Dave, do you have the serial number of your receiver board? It's on paper tape on the back of the module.
Mine. If you give me a moment, I'll get it for you.
Okay, I'm trying to keep track of modules by serial number. It'll be the last 3 digits on the tape.
Looks like you have to take it off to find the serial number.
Yeah, you do. So anyway,
Good.
if
Give me a
that's time
moment.
consuming, just send me an email later on with
No,
that.
no, I can do it while we talk, but I just have to take it off. .006.
Okay, excellent. Thank you.
Yep.
All right, if nobody has anything else,
Go ahead.
what I'd like to do is I'd like to go through and show the group what I've done so far on the RX-888 as far as preparing to feed the data into GNU Radio, and what I've done in GNU Radio to presumably make use of the data, and maybe somebody can show me the error of my ways. Shall I do that, Dave?
Go ahead.
All right. Let me show you. I guess I need to share a screen. Select window or screen. Man, I don't know how to. Wow, there's a. I'm working on a Linux box here, which I haven't used in Zoom before. Okay, let's just say entire screen. Well, no, that's not going to work. All right, let me. Sorry, excuse me, I haven't done this before on using Linux.
Dave, I do it on Linux. I find if I have the application, oh, there you've got it.
All right, so let's stop that. All right, I've got nothing is running at the moment on that's RX 888 related. Okay, I have a script that starts the RX 888, the necessary utilities to begin working with the system. So let me show you what that looks like. All right, if you take the KA9Q radio main and using from GitHub and you clone it to a project area, and then you have to go through and compile everything. But then what you can do is you can create a script like this that runs, that starts first the RX 888D G5RV package first, that program first, and then that collects the data from the 888, and then the second step is radio D, which selects out the HF portion of the large package of data you're getting, and then you run that, and that starts. So let's run that. Okay, now it says a bunch of stuff failed, but don't worry about that. That's just permissions related stuff. So now we have it running. And if I start another screen, wow, sorry, once again, this is something weird's going on with Linux here.
Yeah. Bill, Phil is commenting. I think he's engaged in another conversation, but you can see from the chat window that that's no longer the way you should be running his latest package. The RX 888 support is now built in directly into Radio D. And so there's no need to run it separately. And the way I start and stop it is through system control. You do system control, start, radio D, @ whatever the configuration file you're using. So the start and stop mechanisms are quite different than the ones you're using. And if you're using, so I think Phil would suggest that that you do a get pull and get his latest 9Q code. And
well, this get pull was like last week. Has it changed since last week?
Yeah, it's all been he'd been working over the weekend. He and I have been in constant dialogue for the last 7 days. And chatting on Signal.
Well, okay, but I wish let me show you what I've got working so far before we start changing it, because it is partially working. Now, I'm not sure what screen you're seeing. Are you seeing a screen where it's showing top?
Says resource.
All this has changed.
Early on.
There's no longer an RX 888 daemon anymore because it wasn't fast enough. The mechanism wasn't fast enough. That's why it had to be merged in.
Okay, so is there documentation on how to do it now?
There will be. I realize people are already trying to use this. I thought it was just I thought it was just,
I think Clint's documents are, well, maybe we need to get Clint in here, make sure I have, Phil and I have been working it's been so intense, and I just got the first things up running yesterday with his
Okay,
code.
well,
So-
hang on a second. We're working on 2 or 3 different things at a time here. What I'd like to do is I'd like to show you what I've done by way of the code, but man, I try and figure out which one of these many screens to show. No, that's not it. My apologies. I can't figure out which. I want to show you the code that I've changed, that I've come up with. That's not it either.
okay, it's probably best at this point to restart with the latest stuff on Git and redo the config file. If you look at radio D at RX888-generic, you'll see what it should look like.
Okay, you said radio D at RX888 dot what?
Generic.
Generic.
.conf. And now there's just one program, not 2.
So did RX888 daemon go away?
Yes, it's gone away because it just wasn't fast enough.
I hear you. The frustration I was having was I think I must have pulled the code before you actually got rid of RX888D. So,
I didn't realize that people were already trying to use this other than Rob and me. That's the problem here. I didn't realize that. Sorry about this.
Oh yeah, we've been banging our heads against this for weeks now, man.
I got a question about the data. Okay, I'm able to get the data packages. I went through into PCMcat, the PCMcat program, and after the place where you do a receive from, I added another statement in which I do a send to. So I'm sending out a UDP packet that because GNU Radio doesn't apparently support multicast. So I'm sending out a single cast, which I'm successfully picking up in GNU Radio. But my question is the data. Now, the data that is coming in those 2048 byte packets, is that simply what I think it is? It's a signed 16-bit little endian set of samples. Is that what that is?
I don't remember if it's little or big endian. But there is if you look at the packet as it's coming in, it has a real-time protocol header on it with sequence.
Oh, it has a header.
Yeah.
Okay. Is there a documentation of the layout?
Well, yeah, RTP is a standard protocol. I mean, it's used in voice over IP. PCMcat strips all that off.
Say that again?
PCMcat strips that off and gives you a sequenced output with zeros in place of any lost packets.
Okay, so rather than simply taking the buffer and turning around and sending it, yeah, I know PCMcat outputs it to standard IO.
Right, standard output, that's right.
And I guess I need to collect that all into a buffer and output that buffer rather than.
Well, wait a minute, I don't understand. I mean, what does GNU Radio expect to see? Can it read from a stream, or does it require UDP?
Well, I'm not sure how to answer the question. Because it's what I'm familiar with, I was planning to feed it a set of UDP packets.
Okay, but I don't know what the UDP format is that the GNU Radio expects to see. I mean, the one I'm already sending.
I can deal with that. I can deal with that. I think I can. It looks for the data to be in 32-bit complex format. Well, okay. You can feed it just about anything, and then you can manipulate it inside of GNU Radio into the 16 or the 32-bit complex format.
Right.
So, all right. So
that's not what I mean. What I mean is, what's the packet format it's expected? I mean, it wants to see UDP I mean, are these UDP packets that contain RTP? That's what I'm sending. I mean, what I
Yeah,
send
I honestly
is
don't know.
basically a voice over IP stream.
No, I don't know whether it's looking for VoIP format or not.
Yeah,
See, that's what I need to know.
the standard UDP socket in GNU Radio does not expect any inner protocol. There are other streaming things available in GNU Radio, but the simple modules don't do it. I can't, I think you can do it with like GStreamer, where you can decode RTCP and pull out the data. I'm not sure. I think GNU Radio, I think you can run it through a pipe to GStreamer to undo that stuff.
But
Okay.
So Phil, are you still, are you assuming then if you've merged RX888D into Radio D that you are plugging your hardware radio into the machine that's running Radio D?
That's right.
Okay.
Oh, that was the case before anyway, because the network's not fast enough to handle the multicast stream from RX888 at full sample rate. Now I
right.
can.
It was completely hosing my local network.
Right. Right. And yeah,
so
that
good.
is yeah.
So we do not have to deal with network protocols under these circumstances at all.
Not between the RX888 and Radio D. That's what's
right. That's what I mean. That's what I mean. Right. Not at all.
You will have,
yeah,
you'll have another problem though, which you've encountered, which is that these multicast streams, the demodulated streams that are specified by default will go out to your switch. And if your switch is not IGMP enabled, it will treat them as broadcast packets and deliver all the demodulated streams that you specified in the Radio D config file will all go to your switch and will be delivered to every device on your network.
Right, but that is not a problem, not as much of a problem, because the data rates there are much lower.
Yeah, I was finding my network got hosed even without running Radio D, just running RX888D.
Yes,
well, yeah, RX888 would be the problem, yeah, because it would do that. Right.
It was trying to put out what 3 gigabits if you were running at 133 megabits. You were getting,
over 2, yeah,
2 gigabits of raw samples were being multicast. That's no longer the case.
Right.
But I had just, even in our situation where I was just getting the whisper packets, through 20 to 30 megabits of whisper that was being multicast by Radio D was overwhelming some of the devices, especially if you have a Wi-Fi access point attached to your network. So I think, Phil, can't you configure, if you suggested if you put in a TTL equals 0, that Radio D would not actually deliver the decoded multicast RTP streams, would not be delivered.
That's correct, as long as all consumers run on the same physical machine as Radio.
Yeah, the consumers. I mean, I've been very successful. Whisper D runs 100% CPU for 30 to 40 seconds of each 2-minute cycle, and doesn't seem to interfere with the operation of Radio D.
Right, Radio D runs a real-time priority, so it should get whatever it needs.
And I I run all my Whisper D decoders down at NICE 19, so so I do what I can at the user level to make them as low a priority as possible. And I've had no problem on either of the two machines that I'm.
In practice, if everybody has gigabit networks, the only problem you're likely to run into in practice is if you have Wi-Fi, a simple Wi-Fi hotspot on the same net.
Yeah.
So, Bill, what you're trying to do, which is feed network packets from the RX888D to GNU Radio, at this point is obsolete. And my what I've been toying with, just but not successfully yet, and you may be more successful than I, is using what work has already been done on trying to prepare a SOPI module that will run under the SOPI architecture that can talk directly to GNU Radio. So GNU Radio knows how to talk to SOPI, and if you add a module in SOPI that can manage that particular hardware, RX888, that on your same machine, no network protocols, no nothing. That's the direction I'm going for getting an output from the RX-888 into GNU radio.
Yeah, if you just
Well,
want
what GNU
one
radio
channel
block
or so, that's
reads
fine.
what GNU radio block type reads SOAPy protocol?
There are tons of SOAPy GNU radio block types. I mean, SOAPy builds, GNU radio reads it. I mean, it provides interfaces to a whole bunch of different kinds of hardware directly into GNU radio. And so there are some modules that people have written. I haven't gotten them to work yet. This is what I'm currently working on, but
Yeah.
that will add RX-888, like just like an RTL-SDR, just like Lime, just like a Open HPSDR, just like a bunch of, not for SOAPy, but there's a variety of hardware radios that SOAPy provides a generic interface to that, and a wrapper that will talk to GNU radio and provide sources to GNU radio.
As long as GNU radio can handle that 2 gigabit fire hose and pull out only what it needs.
Yeah, I mean, what I'm trying to feed to GNU radio is not a big fire hose, but rather a single channel. I want to feed it just the 10 megahertz signal.
That's what I figured we're trying to do. Yeah,
that's all I want to do.
Yeah.
And if somebody can give me a single example of one RX, rather GNU radio module or block that can do that, I'll be happy to use it. Other than that, I feel like I have to go into PCMcat and then set it up to output that one channel.
I'm not a GNU radio user myself, so I would need help on that from somebody who does know it.
Phil, there was one question that I had. Does Radio D have the option, instead of outputting a demodulated product, can it output IQ data?
Sure. IQ is one of the quote unquote demodulation options in Radio D. Sure.
Can that IQ data output be written to disk, written to files, series of files?
Sure. Well, with a separate program called PCM record. Sure.
Okay, so the PCM record utility can take that IQ data from Radio D and then write it to files.
Right. Rob's already doing that with a modified version for his Whisper Daemon package.
Yeah. What I learned was that Phil's delivering RTP packets, a series of them, each of which has 492 bytes of 16-bit PCM samples in it. And so I just I just use his code to flip the bytes to the wave files order and just write those 492 bytes out one at a time. So if you write a loop and read in and look at his PC, I guess it started with PCM record. If you look at it and look where there's a stock receive or whether the buffer comes back and that buffer has your the samples data in it. And I don't know how many samples of 492 divided by 16, whatever it's 80 some samples per packet. And you can buffer them up and put them into a UDP packet that you would send out. But so I think you're on the right path, Bill. I think you're on the easiest path to solve this problem. I think you're going to have a hard time, Michael, with a SOAPy API. You need to talk to Franco about if that driver, if there's an interface between the SOAPy API and his driver, because this thing is such a fire hose that his driver would have to do a bunch of filtering and such, I think, before the SOAPy demodulator could get to it. So,
Rob, one thing that I wanted to mention, in your application for Whisper Daemon, you obviously require the demodulated audio, but for the Grape, Bill requires IQ data. He does not need demodulated audio. So what I was thinking is using PCM record to take a a slice channel from radio D of IQ data, writing it to the disk as a temporary buffer or a circular buffer, and then setting up GNU radio to read those sequence of files. And then that's how the graph would
Well, that's one way to do it, but I can already give you an IQ stream at
Right,
whatever center frequency you want. So, I mean, it's just one of the multiple options.
well, I only said that because it seems like there's some difficulty getting that IQ stream into GNU radio, and that's why that I just thought of, using a disk buffer. But if there's another way to get the IQ stream into GNU radio, then this should be easy to set up.
Well, I'm sure there is. I just have to know what GNU radio wants. That's all. The problem is GNU radio, not anything on my end.
Right. Yeah. In that case, well, I don't have a system to set up GNU radio right now, but for people who have it set up and based on the documentation, could you guys work with Phil to work something out?
I just need somebody who knows GNU radio to tell me what it needs, and I'll make it.
Well, okay. I mean, GNU radio, at least theoretically, is able to take virtually anything, and then you put together a series of blocks to convert it to what's necessary to do the analysis.
So
now, if you want, but let me finish.
Okay.
If our objective is to have the GNU radio piece to be as simple as possible, then we would send it a UDP packet that contains complex 32-bit samples. I guess that's
Yeah, I can easily do that. It's just you have to tell me what goes in that UDP packet besides the samples.
So
nothing besides the samples. Now go ahead, Tom.
Right. So it depends on the out-of-tree module or block that you've installed into GNU radio. There's a couple of stock blocks, one of which is a UDP sync. And it just takes a UDP packet and it treats what's inside the packet as bytes. And that sync can be configured to output it interpreting them as 32-bit floating points or 16-bit binaries. There's a couple, 3 or 4 options there. You can install an OOT module, an out-of-tree module. One of those is SOAPy. And what it does is decode the SOAPy format and then spit out the equivalent samples into the rest of the GNU radio sample tree. I wrote the module for OpenHPSDR, and it takes the OpenHPSDR UDP packets that have some magic formatting, undoes all of that, and spits out the samples into the GNU radio flow graph. At the exit point of that block, as Bill says, you can then transform them into a variety. You can do format conversions, sign 16-bit to floating point, whatever you might need. And so if what you have is a special format, you can write an out-of-tree module in C to process it. There's also the ability to use pipes to get things, out of GNU radio into some external processor and back into GNU radio. And there's one package that does that. I forget what it is, but I think it uses GStreamer to undo RTCP or one of those real-time streaming formats. So there's 5 or 6 ways that it can be done.
Well, Tom, the reason I didn't like raw UDP is what happens if you lose a packet? You lose sample count.
Right. So that's if you use the raw socket block in GNU radio, then you have that problem. In OpenHPSDR, there's a 32-bit number that always increments. And so the driver I wrote checks that to make sure no samples got lost. it's amazing how rarely they get lost.
Well, that's what RTP is for. Has a
Right.
timestamp. So,
Right. So, so GNU Radio can handle that. I don't believe there's I don't believe there's a module built into GNU Radio that handles that natively. There may be a module that's available that you can install to GNU Radio to take care of that for you. If not, you can pipe it through GStreamer, which will then do that and send the samples to GNU Radio.
okay, well, it sounds like there's a way to do it, but it's kind of beyond where I come in. I mean,
Yeah, I
send an RTP
have
stream.
lost track of the out of tree modules. I'll go
Yeah.
see if somebody's written something embedded that can do that. Otherwise, you know, it's not that hard to write your own block.
I mean, RTP is a very widely used protocol. It's standard in voice over IP, which is why I picked it. And I didn't want to reinvent the wheels. So it really ought to be a standard module in GNU Radio.
Well, if somebody's written it, then there is. If somebody hasn't written it,
Yeah.
then there
Yeah.
isn't.
I wouldn't be surprised if it's out there.
Yeah, we could do a search.
All right. I want to get out of here and get over to a local meeting. People have more questions, just send me email, Carn@k9q.net.
Thanks,
Okay,
Phil.
thanks very much, Phil.
Sure thing. All right. See you
Yep.
guys.
Thanks, Phil.
Yeah, I mean, you know, from what you've described, Bill, it seems like you could just take the payload of the, if you've already done this, take the payload of the RTP packets in PCM record and just send out a UDP unicast or whatever you want, or multicast that just carries that as a payload.
Yeah, it can just be another program like PCM record, except it just spits out a UDP stream. If the
But just the payload
unicast
gets
stream,
rid of the RTP header. It
if
just,
that's what you want, and turns it into into unicast, if that's
Yeah.
what you want. To me, it's a kludge, but if that's what you want, then it's easy to do.
Yeah, well, I'll look at that. Yeah,
Okay. See you guys.
thank you.
Bye, Phil. Yeah, I found Phil's code quite easy to modify. I went through and hacked away at it, and in a day I had my WAV file recorder from his PCM record. So it's and it's a client program, so I just invoke it from Whisper Daemon. It's not even built in my it's WD record is what I wrote. Yeah, and he added it to his project, but I'm the only user, I think, of it, and I don't think it's particularly relevant to what you're trying to do, Bill. But it was very easy to do. So.
Well, and I mean, there's also the possibility that Phil could write a utility to create digital RF data. And then in that case, you don't even need GNU Radio.
Well, no, I'm outputting digital RF from GNU Radio.
Right. No. But
Yeah.
what I'm saying is if Bill could create a utility to do that, you could set the bandwidth of that channel from Radio D and input all the header information that would be in the digital RF header, and then that will give you your IQ data slice in digital RF format.
Well, yeah, you've given me an idea. I mean, I could probably add the code to output digital RF and add it to PCMCAT. It's just that I like using GNU Radio because the thing about it is you can do a little signal processing to it, and you can have a waterfall output. I mean, there's a lot of nice things that GNU Radio gives you to make the thing more usable rather than just spitting out files, which I really like. So.
Well, right, yeah, no, and I understand that, but I mean for the purposes of once this is deployed and you want something that is just going to create data, then you know, that's when a small lightweight utility, you know, would be beneficial. But no, I understand for diagnostic purposes and for making sure that everything is working, and the graphical options and everything else like that would be useful.
Yeah, well, my experience has been this stuff breaks all the time. So the diagnostic, you got to have your diagnostic tools ready to go at all times.
Right. Yeah.
We're making progress though.
And there might even be a utility in the future in Phil software that can say, you know, that might be based on X forms or something like that, and you know, you could have a nice waterfall display and all that, but you know, it just isn't written yet. And I'm going by all of the tools in VLFRX tools. There's so many different tools and utilities, and it's very much like K9Q radio. And there are some graphical utilities too that allow you to do a lot of diagnostics. So this is just the initial stage, but the more that we help Phil and give him what we need, and you know, lay it out in a very useful manner, I think that you know, we can make this into something very useful. Because honestly though, like, you know, you need a lot of dependencies to run GNU radio, but you don't need that many dependencies to run K9Q radio. And it's very modular. So I mean, for the purposes of getting systems out there, not only recording data but processing it at the same time, much like VLFRX tools does, you know, the more useful utilities that we add to this, the better it will be.
Yeah, I am a little bit concerned about the ability to run all this on a Raspberry Pi. I mean, I've got a Core i5 Intel laptop that I'm running it on, and it puts a pretty good load on it.
What bands are you expecting to be listening to?
Well, generally, to be consider, I mean, typically what our Case Western Reserve colleagues have been collecting is data around WWV at 5, 10, and 15 megahertz.
Okay, so well, you know, the CPU demands of Phil's code are directly related to the sample rate that you set for the 888. And by default, the 888 samples at 126 megasamples, and that'll chew up an i5. You know, and on my i5 6500, it chewed up 60% of the CPU. So I changed the sample rate to 66 megahertz. Now, I need an alias filter, okay, in front of the anti-aliasing in front of it, which is in fact a subject you might be interested in. But in any case, with the appropriate anti-aliasing, 30 megahertz aliasing filtering, my i5 6500 is now 80% idle. So if you want to go to 30 megahertz on an i5, you know, if that's all you want, you can halve the CPU demands. My next attempt is to take this Orange Pi, which is you know, $100 single board kind of a thing, cheaper than a Pi 4 these days, and 3 or 4 times more powerful CPU power. And I'm going to try to run Phil's code on that and see how well it runs. But sample rate really very much directly affects the CPU demands. And if you haven't set your there's a config file variable. In the config file, you can find a setting where you can change the RX-888 sample rate. And that's, you might want to try that to make it appropriate to the bandwidths you're actually looking at. And if I poke around here, I can find the line in the conf file but it's in there. It's remarked out where in the section about the RX-888 in the config file, there's a section where he has a remarked out line which shows the default 126 XYZ megahertz or hertz equals sample rate, or sample rate equals 126. If you look for that line in the conf file, you can change that to some lower value, and that will free up a lot of your CPU. Now,
well, I mean, the laptop that I've been running this on is I think running it at the default rate. I think it's running it at 40% load, but still, I mean, that's more than a Raspberry Pi has, though. I mean, because
yes, I know that Phil's code runs well. Okay, runs well with RTL SDRs and a 10 megahertz bandwidth, for VHF stuff. So Pis are able to support that, but that's of course half the sample size and 1/3 the sample rate. So I kind of don't pay attention to Pis anymore, because even though I have a dozen of them, they're just too wimpy for whisper processing anymore. So I keep it working, but I don't spend much time with them. But it will run. But you can try it out, plug it in, and then lower the sample rate until the Pi works. Whoops. Yeah, so we lost somebody.
Right. Yeah. Rob, that's a very good point. Is because if you don't need to capture all that bandwidth, then there's no point in having your CPU work that hard. So if you have some frequencies of interest, then you would just lower the sample rate accordingly. With VLF RX tools, you often have that option. Actually, you can resample, even though you might capture at 192 kilohertz, you could resample to anything you want, all the way down to 1 sample per second. Yeah. You could change the sample rate of the IQ slices out of Radio D, can't you?
You can change the size of the various parameters, but the sample rate is the key one, because the sample rate determines how much data is coming down the USB 3 pipe, and all of that data has to be run through the FFT twice. And so you'll see if you run top -HC, I never used these options, the top before. But if you do top space -HC, you'll see the FFT threads and how much CPU, and there's 2 FFT threads running. And each of them consumes about, well, it depends on your CPU, but they equal amount. But they dominate, those 2 FFT threads dominate the CPU usage of the whole system until you fire up the whisper decoder, at which point
what is that top again? Top capital HC?
Dash, it's an option to the top command, and it's -HC, Charlie, Hotel Charlie.
Because it comes up and says unknown option C when I do that.
What OS are you running on?
Ubuntu.
That's what I run here. It's hold on a second. And
Capital Hotel, capital Charlie?
No, lowercase Charlie, lowercase Charlie. Capital, okay. I'm sorry, I wasn't clear.
Okay, I see something. What is this telling me?
It's telling you, it shows you threads, and you should see the top listing would be the 2 FFT threads that are running. They'll be at the top of your top list.
I see RX 888D G5RV. That's at the top.
Here, can I?
Then now, well, you know, I'm also running Zoom. So in Firefox,
Well, that may interfere with it. Here, let me just, I'll briefly share my screen here. You can see this is you see that?
Well, yeah,
Okay.
yes and no.
It's a wrong. It's a wrong. Let's see. Hold on a second. Is this the one are you seeing? My Zoom isn't showing me what I'm showing you.
Yeah,
I think that's similar. It's too small to read, but I think it resembles it. Yeah.
Well, here I'll make this. I'll make it larger.
I put my glasses on here.
Okay, it's at the moment it's running the decode. So JT9 is, you know, in a minute you'll see. Here's, well, maybe, you know,
that's showing what you're saying.
Are you seeing my top command here?
Yes.
Okay, I have the right window because I can't see what I'm showing you. So this is actually this is a think center in Austria, but anyway, so this is a command top. Can you see? Is that readable to you guys?
Yeah.
Okay, so and you get this, and you can see that now there's nothing else. This is a headless machine, so it doesn't have anything else running. So you can see that there's the two FFTs at the top of the list, each of which is consuming 30% of one of the 4 cores. And then there's the proc RX888 below it, which is doing the decoding work. And you can see how little CPU it's consuming. Yeah,
I don't see the FFT on mine.
Are you actually?
Are you sure? Then maybe are you sure it's running? Then are you actually getting?
Well, I see the top is /RX888D G5RV.
Well, this is, you see, this is a regular top. Okay, so this is the standard view top with no arguments. There's, you're seeing the whisper D is firing up, and the whisper decoders. So, so they're CPU hogs, but they'll go away in 10 seconds or so. But this is what you would see something like this for if 9Q is running in normal mode. And if you want to look at it down deep and look at the threads, then you add the -8C and you get this view. So this is, anyway, that's, if you're not seeing that, then something's wrong with your 9Q configuration. So
the FFT utility, is that a utility that's in K9Q radio?
Yeah, that's all built in. It's built in. It's not a separate program. Everything. This is the new code now. The old code. Oh, you know, that's right, Bill. You're running his older code with a separate RX888. It's going to look different.
So you're invoking, Rob. You're invoking Radio Daemon. That is the only program you're running, or to start the thing.
Yes, and I don't do. You don't run it within. You run it from system command D. So sudo system. Oops.
Okay. System control enable.
Yeah,
status.
Enable it
initially, and then
this is radio. There's okay. So that's the. So this you would you would do a start, stop, enable, disable to start it up. All of his code runs as off of that daemon. So you just and so this is so you can see it's just enabled, and it's active. And if you want to stop it, you do a stop and do a start. But that's the.
I wish I could read that because I bet it's really cool.
Okay, here I can make it larger. I'll keep making.
It's only like 2 or 3 pixels.
What I'm blowing up my terminal window here. Does that help?
System control status radio at RX888.
Well, that's the config file that I'm using. Radio D's the config file that's being used at this site. So I've just learned that this name tells Radio D to go look in the ETC radio. Okay, RX. Let's see. I'm sorry, Radio D. This is where you put your config file. Let's see. Yeah, CD. I'm sorry. Let me. Are you seeing what? Is this large enough for you to see?
Yes.
Okay. So so these are all kind of prototype config files that are here that he creates. But the only one that really your only thing you do is invoke. You do a system control start, and you specify the config file Radio D should use. And in this case, we're using where is the OE9? I don't see the OE9 GHV. Am I missing it?
You said that was on a remote radio, a remote site?
This is over in Austria. So that's
maybe that file is somewhere else.
This is maybe it should be
in
here.
System. It's in Etsy system D system.
It's a system. This is where the maybe he wants it in there. I forgot system. I'm just learning this. I mean, I've been working with Phil over this, and star conf. Let's see if there's a conf file. Whoops. No, there's no conf file in the system directory. There's Radio D at service. And this is all new system D syntax to me, but apparently this syntax where there's an @ sign, then when the service starts, it goes and looks for the argument that was passed in the system control D, and it goes and looks for that config file. And I thought it went and looked in the ETC radio directory by default. I don't know how let's see how it was configured. I think he may have started this from a private directory or something. Oh, there's ETC. Oh, this is so large. Let me just scroll this over. Radio D RxX. It says it's there. Why didn't I see it when I went over there? It says there's ETC radio. Whoops, you can't see it, but it just passed. But this is saying that's where the conf file is supposed to be. So I'm not sure if Clint's got this installation and configuration mechanism into his documents, and I haven't had time to talk to Clint since I talk with him mostly each Wednesday. So I'll talk with him about his blog entry about configuring 9Q on Wednesday and see if we can't get this. There it is. I don't know why I didn't see it. Here's the config file that is running at this site. And so So this is what a config file, this is derived from the RX-888 generic. And you can see this one is running. Let's see, let me do this where I can highlight it for you. Is this, are you following this, Bill? Does this make sense?
Yes.
Okay. So you can see down here in the 888 section, here is this, where you can set the sample, change the sample rate. That
Yeah,
he
that's all
remarks on.
commented out, but you can take off the comment,
You
right?
take out the comment and change the value. As he says above, at the beginning, the hashed out lines are show the default value. So and the SDCC, that image file, is included as part of his package, so you don't need to go and find it. Everything here is
Right.
part of his. You just do a get pull, and this could, you know, you're off and running.
Well,
Pretty
you
much.
do have to, if I recall, you do have to go through a process of setting up the make file and compiling everything.
Yes, you have to link the appropriate make file, ln-s, and then you run make and make install, sudo make install. And then he doesn't say it, but once you configure it, then you have to do the sudo system control start radio D. So that's as you can see on this site, we're running the Whisper package, and we're decoding all of the Whisper bands simultaneously, including 22 meters, which isn't a ham band really, but anyway. But we disabled the FT8, and you can disable all the things you're not using. They don't consume a lot of CPU time, but you know, why have them? And if they are enabled, they will be multicasting. So you'll have more multicast packets out there than you want.
Rob,
Tell me what again, what is 22 meters?
I'm sorry?
What is 22 meters? You said something about 22 meters?
Oh, 22 meters is the ISM band. And so it's an unlicensed band that's used for, you know, industrial, scientific, medical things. And so anybody can transmit, but you can only transmit 4 microvolts per meter at 30 meters. So you're limited to that. But it turns out that Whisper is so effective that you can hear those 4 milliwatt signals a continent away. It's startling. There aren't many people using it yet, but I'm planning to use it with a friend of mine to put together a beehive monitoring system. We're gonna put these things out, solar powered little Whisper transmitters on the ISM band, and just put out you know, a second pair, just like the balloons put out a second packet, you know, a Whisper packet followed by a balloon format packet. We're going to do the same thing with a Whisper packet followed by a beehive monitoring packet. And
so Rob, when you installed the USB drivers, did you use the FX3 SDK from Infineon?
Didn't have to. No, you don't have to touch it. It's built in. It's included in the. Franco has created the driver, and it's included in the 9Q package. Phil includes that driver, so you don't need to do anything to support the 888 and others. He has the drivers are built in for SDR plays, for AirSpies, for Fun Cubes, RTL SDRs. He has the drivers all built in, so you don't really need to. You don't need to install drivers. They're part of 9Q. It's one of the. It's one of the great accelerators in dealing with devices. I don't have to. You know, you just have to. A user has to understand how to. You know, you take the AirSpy. You can see on. I was showing you. There's a list of devices that are supported, in generic form in his etc radio directory. You can see here is here's the 888. Here's a fun cube. Here's a AirSpy. Here's an AirSpy F. So all these drivers are. I don't know. The Opus has to do with audio processing. I don't know how that works. I don't know what Horus is either. I think here's the FT8 decoder. Well, these are decode now configurations, APRS, all this stuff. But those are devices that are already supported, and he gives you generic versions of how to configure and tell a Radio D how to talk to those attached devices.
So when I plug in an RX888 with by itself, Ubuntu does not include USB drivers for an RX888.
No, if you do an LS USB, you'll see that that there's a Cypress device added. It's running at 480 megabits, USB 2 rate. But if you once you start up 9Q, you'll see that the 9Q runs the Franco's driver, and it's communicates with the 888 and puts it into the 5 gigabit mode, USB 3.0 mode, and starts communicating with it. And it's so much easier than fiddling while trying to get drivers and communicating with Linux and configure them. I think his installer, when he does a make install, he does the mod probe changes that are appropriate for all of the devices that he can talk to. So
when you load the Radio D, can you see the if you use LS USB, can you then see the correct Cypress, different name?
Yeah, here I'll show you on this one. Once I will go back to sharing if you guys want to see that. Here is a LS USB. Okay, you can see there's a. Well, let me do you guys, is this large enough for you?
Yeah.
Okay. USB/T. There's you can see here's the it shows vendor specific class driver UBS. Okay, so if you want to look in more detail, do -V/. Okay, and there's all the information. There's the for that Cypress device. You see it's ID'd itself as an R888. All of here's the detailed information about the.
And this is after the driver is loaded from our from Radio D.
Yeah, before you start up Radio D, this device will not look. It will look. You'll see. It'll identify itself as a Cypress semiconductor, but it'll have a different ID. It'll have a ID product of F3 or something, which is a USB 2 kind of startup mode of the Cypress chip. So when Radio D starts, he talks to Franco's driver. Franco's driver then looks for the Cypress device and configures it and changes it into USB 3 mode. Of course,
that's a kind of a quick diagnostic that you're.
So this is a quick way. A USB, yeah, you can see it even before you load Radio D. Once you plug in the driver, plug in the 888, you will see the device there.
Right.
And of course, if you don't see it, then you have a really a USB compatibility problem.
Right.
So that's what I would do. Plug in the 888 first. Do a USB just -T, like this. It's always not clear. It doesn't show you the -T doesn't show you the vendor information. So you have to do verbose, and then that spits out a lot of information, but if you search down for Cypress, you should find it, and it will identify the USB bus and device that's where the 888 is attached.
It looks like that the way this works is that it loads a generic driver, but K9Q radio has its own driver for the RX-888.
Yes, exactly. It has this Franco's driver is incorporated into 888, and if you configured 9Q to talk to a 888, then a 9Q tells Franco's driver, go look for and initialize the 888.
Right. Yeah, because VLFRX tools, VT card is only able to read or only able to talk to ALSA and OSS drivers. So if you're talking about FreeBSD sound drivers or something like that, it obviously can't do it because it uses those functions from those libraries. So yeah, in this case, you would pretty much have a custom driver, and which is all included. So yeah, you don't have to worry about. So for anybody who has any driver questions, you don't have to worry about any other drivers. Everything is included in K9Q radio.
Yeah. Now, Franco's driver is open source, and I think it's used by HDSDR and other open source programs to talk to 888. So it's not, the Franco's driver is not private to K9Q. It's just that Phil has incorporated it into built it right in, and he's working so intimately with Phil's with Franco's driver. The data rates, are so high that the timing is, the timing and buffering are all need to be tuned quite carefully. And
I'm sure that's what screwed me up. I went ahead and downloaded Cypress drivers. And they're probably interfering with Franco's driver.
Probably. I'm not very familiar with, driver manipulation. I always found it daunting. So
yeah, well, me too.
In reality, it means a lot of different things in a lot of different settings. This Cypress device is actually a pretty complex device. It's really a full-blown ARM9 with that can run in many modes, and it has a real-time operating system running in it that that can be configured in many ways.
Anyway, this device is running. This is you can see this is an i5 9400, so it's the 9th generation Intel. And this is the BTOP program. If you're familiar, I don't know if you're familiar with it. I find it's a different view. It has other nice things about it. Top, HTOP, they all have, their uses. But this one is a kind of nice, it gives you the strip chart of CPU utilization. And you can see between whisper cycles, when we're basically just having radio D running and USB, the FFTs, you can see that the device is only, 15 to 20% busy. So you will see as we approach, well, there's a little blip here at an odd minute. We're at minute 43. But when we get up to minute 44, you'll see that Whisper Daemon will fire up, and then you'll see all the things at the top of the list. You'll see 100% utilization for for a few seconds for 14 instances of Whisper D decoding the WAV files that are currently being recorded right now. But this is, I think this i5 95-400 is a vast overkill for a single USB, 888 input, but it could be a good platform if you want to plug in. You can plug in multiple RX 888s into a computer and run multiple instances of Radio D. And and then have client programs talk to any or all of them, because the decoded audio there, you see the spike there when the Whisper Ds were running. It's done now, so we're back to background idle mode.
I like BTOP. That's I've never seen that before. So thanks for pointing that out.
It's
I've already
I was-
downloaded it and put it running on my,
it's
on my
yeah,
computer.
yeah, it's built into Ubuntu, so you can just do sudo apt install btop.
Yeah,
and got it.
that's just what I did. It
Yeah.
took just a couple of seconds. It's marvelous.
Yes, I was just introduced to it a while ago, and it's a marvelous marvelous program. You can also, of course, you're probably familiar with oh, probably it's not here, IFTop. I don't think it's no. Apt install IFTop. Well, this will allow you to look at the multicast streams that are being generated by the so you can see that the this multicast stream, I guess I could, what is it? Yeah, there it is, 239.72.24.24. This is a single multicast stream, series of multicast UDP packets, which carries, this is RTP multicast, and this carries all of the Whisper decoded audio from all 14 channels, receive bands that are carried in one multicast stream. So you can see that generates about, you can see about 2.8 megabits in total. Now this is 12,000 sample per second. And audio, 16-bit PCM audio. So that's that gives you a notion of what you could expect if you could see, this is, if you have an unmanaged switch, this is treated, these packets will be treated as broadcast packets and delivered to all of your receive devices. And even if you have a multicast capable switch, you're probably going to have to go in and turn on the IGMP snooping features of it. We had a problem at KFS because we had a quite capable switch, but the multicasts weren't enabled. And the Kiwi SDRs, I don't know if any of you use them. The Kiwis are best run at 10 megabit, 10 base T mode rather than the 100 base T. 100 base T introduces in many receive sites, introduces landlines up in the 20 to 30 megahertz region. So to avoid those, there are several ways to do it, but one simple way to do it is just force the interface to run at 10 base T. Well, when I did that, and K9Q turned on, it started to send 12 megabits of multicast to each of the Kiwis through a 10 megabit channel. And of course, the Kiwis started to fall over because they were dropping a whole bunch of packets on their receive side. So that's why I tell you guys to pay attention to multicast. Okay, have I burned everybody
I appreciate
out?
that.
Okay.
Thank you, Rob. I appreciate your experience and all the work you've been doing on it. Thank
Okay,
you.
well, as I say, don't if I can be of any help, send me an email, and I think I spent quite some time a couple of years ago getting my WhisperDeem software to talk to SOAPy, and in the end, I decided it wasn't really a good solution for me. It's a wonderful, flexible architecture, but it's very cumbersome and CPU burdensome and network burdensome. So I kind of abandoned all of that approach, as approach to support other devices. And Phil's software has just, one of the free benefits has been that he's integrated drivers to all of these So a good project would be to create a 9Q to SOAPy kind of, server interface. And that probably be very helpful for a lot of people, because right now, if you do SOAPy to you get one channel out of device. So you could take a SDR play, put it into, I don't know, 4 megahertz mode, whatever, and have a dozen different SOAPy server instances where you could have dozens of people talking to that one using the signals coming out of that SDR play. So it would be a far more flexible and not to mention CPU efficient, but more architecturally elegant, software's architecturally elegant approach to SOAPy support would be build it on top of 9Q. At this point, I would build any new projects on top of 9Q. I'm just kind of overwhelmed with the power of this architecture. It's just amazing. Everything I mean, it's just startling me constantly with the efficiency and flexibility and stability. I mean, the thing just sits there and runs. So
yeah.
Okay.
Thank
well,
you.
Okay. Good. Well, you have you know how to reach me, and send me an email if you have any questions. I host a weekly Whisper Demon call in which we discuss. We're now spending most of the 3 or 4 hours of that call on 9Q and integration. Although we do talk about antennas and other things. Okay. Anybody else? I think Dave, you're still there, but off. I think.
I'm
both Daves.
Steve
Okay.
Larson, maybe he may just have left it to record.
Okay. Well, anyway, Dave, I really appreciate your working on this. I'm very enthusiastic about the 888, but the one thing I don't like about it is we don't know who makes it. We don't know where the parts come from. That's going to be a continuing problem. So I think that if we can do at least an initial version that is low cost, but available from Tapper and, from a known and reliable supplier, even if it costs more, I'm going to stop recommending 888s and I will start recommending Tapper, the Tapper 8, 888, or whatever we want to call it. So
I'm kind of clawing my way towards a workable baseline schematic, and I put a couple of people I thought would be interested as collaborators on the GitHub. Ultimately, it would be open, of course, but it's just I've never done a GitHub of a CAD project before, and you got to make sure that all the necessary pieces are there when people pull the project down. And I'm not confident that I've got them all, and all the internal pointers pointing the right places. But yeah, and so I put you on that list, and Michael. Yeah. So I appreciate any comments, but it's early days.
Well, I can't be much help on the hardware, so I can only kind of, I can.
You can, when it comes down to it, we'll want to look at it and say, what do we want in here? It has something a little more tangible than just this discussion that we model.
Well, I have some side projects going on, that are relevant to this design. I mentioned last week the Glenn's low cost GPS-DO, but it didn't seem to stimulate any measurements that I heard of from. I think the next stage was to get John Ackerman to do some.
I actually talked to John.
Yeah.
About that, and he said that he and Glenn were actively working on that.
Okay, well, I don't think Glenn has the same understanding.
I see. Okay.
But maybe I'm wrong. I haven't had a one-on-one with Glenn for
yeah.
for a
I
week.
also tried to put him on the collaborator list for the where I didn't know whether he'd have any interest in it or not. But he may, if he has a GitHub account, I don't know what it might be, or you kind of have to have something on. GitHub has to know who you are.
Yeah. Glenn's design is not in GitHub. It's in his hardware page, which I think I gave a link to Glenn's hardware page last week. So, I mean, he considers it open source. So if you were to include his stuff in a subdirectory, he couldn't get mad at you. Your GitHub subdirectory.
Well, Majid didn't have an account either, but I put him on there, and he just created an account. Doesn't cost anything.
It does. No, it doesn't cost anything. You don't really need an account to pull to do a get pull. If it's private, of course. Oh yes, since it's private. I've never done my account isn't private, so it doesn't mean.
Well, I've just been trying to keep this project private until I know it works.
That makes a lot of sense. No, yeah, I think you're wise to do that. But so if we can, the Franco, I guess, is still RVing, so we didn't see him. But I think his input is probably the most relevant of all here. And of course, that's at least at the USB end of it. And then on the RF input, Glenn's input is probably would be the most valuable. And if we get to that stage, I will try to drag Glenn in, at least for some brief consultations on the RF front end. He's been. Wait a second. Who is he talking to about? Oh, he's talking. Yes, he's talking with someone else about an RF design, a new RF design for SDR. So Glenn has been going through some of those issues with somebody else, and that information I think would be directly relevant to this project. But I think the basic outlines of it needs a low pass, a low pass filter in it that should be 30 megahertz or 60 megahertz, depending how fast you want to run the thing. And then it needs to have the shelving filter almost certainly as part of it. And we have a design that is being proposed for that. So that design could become part of your design. And I know that the designer Paul WB6 CXE would be happy to share his design with you guys. So that's the kind of the low pass filter part of it. Then there's the attenuator, of course, which is Glenn is very familiar with. And then there's a question of how to do the RF amplifier stage. And there are some issues around that he's discussing on this other project. So if you get to that stage, I think if you could, get the kind of the USB section seems to be the area of right now, I think is when Franco comes back, that could be, hopefully that could be solidified. Maybe it seems these things could go entirely in parallel. I'll talk to Glenn about his work and see if it could be shared with you in the near future, because I think it's pretty relevant to talking about probably the same analog to digital converter. And this other design, by the way, won't work with K9AQ, so it's not a competitor.
That kind of a thing, yeah.
So I wouldn't have you guys off working on this if I knew of another another project underway, but I'm not aware of any. But until then, as I said earlier, I'm ordering 888s, but I do it with holding my nose. But so
I don't think they're too bad. I just think that they have gotten the 2208 chips, the LTC 2208s, from some, the idea that they're scraping them off boards seems suspicious to me. They have access to a large number of the higher speed grade. Now there's a lot of design issues seemingly because I keep ordering the wrong reference boards. There's issues about what I really need help with is I don't, these use different kinds of balanced inputs. They do a lot of things to the way to work with the way all these designs are using single-ended LVC MOS. And I have no idea how to go about doing them any other way. The pins are there, but
I mean, this is on the USB, the Cypress side of the.
Well, this is between the Cypress and the AD, and there's a lot of really nervous making decisions to be made there, and that really Tom knows an awful lot of this because he's worked with similar chips a lot, but and I have actually gotten contact with Oscar too. He's agreed to answer occasional questions, but Franco put me in touch with him, so I haven't asked any questions yet. But I want to just collect all the information, all the good information we can. And
Well, I know Glenn is traveling until late this week, so I'm probably not going to have a chance to really have a substantive discussion with him on this subject until Friday or something.
Nothing urgent about that, though. I would like to at least know who all the primary players are and have at least talking to each other before I go off for a couple of weeks in August. We're going to Europe for a couple of weeks then, and but that's my only constraint.
Well, we burned a couple hours here. Hopefully, we've covered enough
something
to put you guys all to sleep back on the East Coast. But hopefully, I can be. As I say, I'm really glad you're all working on it. I think this is a great project, and I'm really glad to see you all working on it, and I want to do what I can to help you guys. So. Anyway,
very good.
Okay. Any other questions? Send me an email. You guys know how to reach me, right? So.
Yep.
Good. Okay.
Hi, everybody.
Okay. Good night.
Bye-bye.